Hey, okay, so all right. I know this has been a lengthy set of notes here, but the good news is the homework itself is quite short in comparison. I mean, you'll be able to fly through it pretty good. So what we're going to do is, and this is a common thing also that you're asked to do. So I love that we're going to see this pretty early. This is definitely the earliest we've ever encountered something like this in one of my calculus classes. And so what we're going to do is we're going to estimate a derivative by using points that are in the neighborhood a little bit. Now I know your argument may be that -4 and -1 aren't the same distance away from -2 and so forth, but that's all the information we have to go with. So what we're going to do is we're just going to use those to estimate the derivative at the point that's between the other 2 points in your table. All right, so here we go. So here's what I'm talking about. All right, so our derivative estimate work at -2. So when we're at -2, and my pen's not working. My pen's not working. And pen's not working. Make him sad. Now my pen is working. Okay, so here we go. So if I'm going to go at -2, and I'm going to estimate the derivative there, the slope there, well, I'm going to use these two kind of bookends to make it work. All right, so here we go. So I'm going to say y2 is 4 minus y1 is -6. And then we're dividing by our x's, which will be x2. So that's -1. And then x1, which is -4. Okay, so up top, we've got what, a 10. On the bottom, we have -1 plus 4, 3. So I'm going to say that that's our estimate of the tangent, slope of the tangent line, when x is equal to -1. So my function behavior there is increasing. Increasing. Oh. So increasing. And my justification then would be, based on my work, my justification is, well, and this is the calculus talk, y prime of -2, we are approximating to be 10/3. Or it's positive. All right, so or you could say that y prime of -2 is positive. That'd be another thing you could say. So we might write that on the next one, something like that. Okay, all right, cool. All right, so let's move to -1. So when x is -1, we're going to use these two bookends. And so my y2 is -1. And my y1 is 2. Okay, and then x2 is 0, and x1 is -2. All right, so up top, I've got -3. And on the bottom, I've got 2. And so that's a negative slope. So we're going to say the behavior at x equals -1 is decreasing. The graph is decreasing. And the reason I'm going to say this time, I'm going to change it up a little bit, f prime of -1 is negative. And that's the reason we can say that we estimate that the slope is decreasing. Therefore, the slope is negative. Therefore, the slope is negative. Okay. All right. So at 0, then, all right, I think I've got room right here. 0, I'm going to use these two. Oh my gosh, up top it's 4 minus 4. All right, and on the bottom, who cares? But we'll go ahead and put it. It's going to be 2 minus -1. So 2 minus -1. This is 0. All right, now think about this for a second. My y values were high, and it came down to -1. So I'm going to say this is a minimum. Okay, and my justification is f prime of 0 is equal to 0, maybe. It might be 0. We're estimating it to be 0. And also, the y values were decreasing before and after. So that would have to be we're higher. The y values were higher than at that point. So if it is true that the slope at that moment is 0, then it would be a minimum. Okay. All right. what else we got? At 2. All right, so at 2, my bookends are going to be when x is 0 and x is 3, because that's all the information I have. So my numerator is 2 minus -1. Okay, and my denominator is 3. 2 minus -1 is 3 over 3. So this is 1. And so again, I'm going to say that this is increasing. Which kind of makes sense. I mean, we had a minimum right before it. So, I mean, but, we could have others, but, just based on what we've seen so far. And so now my justification would be f prime, pretend like that's good, is positive. We could say positive. F prime of 2 is positive. I mean, that's really the reason. So I think I will say that this time. Oops. As long as you're talking about the calculus, they're gonna like your justifications. That's why with this justification thing, it's all about the calculus. There was no calculus over here stated whatsoever. But anytime you're justifying something, the more calculus you can say, the more points you're going to score. All right. So is positive. And if you wanted to say more about that, you could, but that's enough, really. All right, now, all right, so let's see what we got. Now we're doing 3, all right, and so we're going to use the x values of 2 and 8, and so y2 minus y1 is going to be 0 minus 4, so 0 minus 4, and then my denominator is 8 minus 2. All right, so I have a -4/6. Which is -2/3. And so that means if this estimate is even close, then our function is decreasing when x is equal to 3. And the reason is f prime of 3 is negative. And of course, it's it's more than likely negative. Okay, so there we go. So that takes care of that little chart right there. Pretty cool stuff. And that shows up quite often, so I'm glad we have that. This time, let's type. So out of there. Let's go type. All right, so here we go. If f prime of x is less than 0, then the graph of the function, not that equation, the graph of the original function is decreasing at x equals a. All right. If it's greater than 0, then the graph of the function is increasing. Okay. A relative maximum occurs on the function if f prime of x is equal to 0, and the derivative 0, and the derivative. Okay, now think about this. So it's a maximum. So coming from you're looking at it backwards here, just like you're looking at as if you're looking straight from the screen. All right, so that means over here it was going positive, and then all of a sudden it was negative, and then that created a max. Okay, just as you're looking at the paper. All right, so the derivative changes from a maximum occurs whenever you hit the top of a hill, and so to get to the top of a hill, you had to come on. All right, what's it doing? Just switch it up a little bit here. Okay, looks like I'm writing. Okay, so when the derivative changes from positive to negative. All right. Likewise, if you have a relative minimum, all right, so then your slope again is going to be 0 at that minimum. But then think about how you had to get to that minimum. You had to travel down to get there and then up afterwards. All right. So that means the derivative would have to change from negative to positive. All right. Okay. Now, so tomorrow in class, we'll be working on this 2-3 homework, and I think it's going to go pretty quick. So I think we'll be ready to start 2-4 notes. I might work on a little bit of that this evening, or I might wait till planning tomorrow. But either way, I'll have 2-4 notes ready for you. Now, 2-4 is about differentiability, and then we have the shortcut rules coming, and a quiz coming up soon. But I think I want to do a quiz after we have completed our first little bit of our shortcut rules. Okay, so we'll talk more about that in class. All right.